Hello, this is the beginning of a new video. In this video, I'll be continuing Highlands from the previous video. Now, this time I'll be doing non-uniform slopes, right? Change the color here. Non-uniform slopes. Okay? Now, the spaces between the contour lines, they get smaller as the values of the contours get larger, right? Now, this happens, right? The values, right? So the values of the slope are steeper, right? So when the values of the contour lines, when the values of the contour lines are bigger, then the slope is steeper, right? At the top more than at the bottom. Let me repeat that again. Now, if the spaces between the contour lines get smaller as the values of the contours get bigger, then the slope is steeper at the top than at the bottom. Okay, so in case you might not understand that, let me make a representation of that. All right, so this is a box. Let me draw a box here. Yeah. Let me erase this. Okay. I'm drawing a box right here. Right? So this happens, right? At the beginning, you notice that the slope is very large. Right? The contour lines have large spaces between them. Right? Until you reach that particular point where it just gets smaller, like this, smaller, 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 right? Now, this is what we would call a concave slope. So when you notice that this area has a white space, like there's a white space between the contour lines, and then you see where it gradually gets smaller and smaller, that is what you would call a concave slope. Now, this is how it would look on the graph, right? This is how it would look on the graph, right? You would see it coming down like this, right? Better yet, let me draw it a little more. Yeah, you would see it coming down like this, right? So that is what you call a concave okay. Oh, okay, I'll just leave it there. Concave slope. Yeah. Yeah. In both. Concave slope. Right? Now let me erase. I'm just going to use the same. Oh, never mind. Okay. Now, when you realize that the contour lines, the spaces between the contour lines, they are very small, and then you realize that they get larger, like the spaces between the contour lines, they become larger, then that is what you would call convex slopes, right? So let me do a representation of this. Oh, yeah. So you notice that the contour lines here, they're very close together. Don't mind me drawing outside of the lines, right? And then you notice that it gradually gets larger and larger and larger and larger, right? This is what you call a convex slope, right? Now, a convex slope would look more like this. Like, yeah, that would look like a convex slope, right? Where you notice right here is steep, you notice right here is gentle. Now, this can be an escarpment where you have the scarp slope right here and the dip slope right here. If right here was going downwards like this, of course. Okay, never mind that. All right. Now, this, as we know, is a convex slope. Now, that one didn't rub out at all. Okay. When you notice that the slopes have groupings of contours, like it has maybe one or two groupings and then there's a wide space, one or two groupings and there's a wide space, and there isn't really a general gradient. So it's like it's interrupted by steeper sections, like it just grouped far apart, grouped far apart. This is what we call stepped slope, right? So this is what you'll be noticing. Like you seen it like this, and then big gap. You seen it like this, or maybe three, then a big gap again. Seen it like this. Oh, you seen it like this. Oh, it's a big gap. Don't mind the joint, right? So it's like you're seeing a grouping here, a white space here, a grouping here, a white space there, a grouping here, a white space there, a grouping there, a white space there, right? So it's like you have gaps. So it's like you have one or two contour lines, or even three. They're being grouped together and being very close to each other. And then you notice that there are gaps of white spaces. Now, this is what we call stepped slopes, right? This is what we call stepped slopes. Might have to erase that right there. Yeah, I'll deal with that later. Stepped slopes, right? And on the graph, you notice that it would look like this. Oh, like it's looking like it would be looking like terraces, right? Like steps, right? So that is how it would look on the graph, right? Now we'll be looking at the types of hills, right? Now, next lesson today, types of hills, right? Now, as I said before, a hill would be a landform that has a height of less than 600 meters, right? So you have the various times of hills, right? Now the steep circular hills, right? With regular slopes all around. These are called conical hills. Now they're shaped like cones and they usually taper at a point, right? So let me give you an example, right? Trying to draw a hill right there. Now bear in mind that hills aren't normally perfectly shaped, but for the sake of the video, I'll just be letting it look a little neater, right? Normally, landforms aren't perfectly shaped. So this is point A, this is point B, right? So by this area, so this is okay. So this contour line right here, let's say that it is 700, 600, 500, 400, and 300 meters, right? Just multiply them by 100, right? Good. Now, on the map, they would look like this. So they are normally cones. Sorry, this should not be so flat, right? They are normally cones that taper to a point, right? So they look like cones, right? Now these are called conical hills. Write it. Conical hills, right? No, conical hills taper at a point. Good. Okay. Now the next one we'll look at is the round top hill. Now, unlike the conical hill, the round top hill, it would not taper to a point. It will just look round. So the contour lines for this now would be like, oh, yeah. It would be like maybe this. Yeah. Round top hills are normally gentle sometimes, but not always. Now, instead, right, the space within the innermost contour is normally comparatively large, right? So, as this shows, it has a large contour line, right? Simply because it is round, right? Now, these hills are normally represented by roughly circular inner lines. Now, these aren't, as you can see, they're normally rough, right? No. On the map, sorry, on the graph, it would be represented like this. Oh, yeah. It would be represented like that. Ooh, yeah. They don't taper to a point. They don't have a specific point. They just, you know. So these are examples of round top hills. Good. Now, the next one that I'm going to look at is flat top hills. Now, in the flat top hills, the innermost or the highest contour lines, it normally encloses a wide space. Now, the contour lines aren't normally circular in shape, right? No, you would see it being represented like this. So it almost looks like a square, right? I'm just going to do about 3 contour lines. It would look like this. On a graph, it would then look like this. Wherein you would have the top part being flat. Another example is this, right? Now these are examples of flat top hills. Don't mind this. This should be straight. Oh, right? Now the others would be examples of flat top hills, right? Now the next one that we look at is a null. Now a null is a small rounded hill or a mound that is normally isolated from the group of hills. So let's say you have like a group of mountains right here, right? And you have the river flowing and stuff, right? Yeah. Pretend that these are tributaries and they're flowing. And then you just have this circular thing right here. Like it's just so far apart from the others. Right? Now this is what we call a null. Now a null is what you'd notice like in a map. The mountainous areas would be around like this. And then in the middle of nowhere, you just have these 2 contour lines or, representing mountains. Now, this is what we would call a null, right? Another area, right, is what we would call a plateau. Now, a lot of persons are familiar with plateaus, right? So these are large highland areas. So they normally have wide flat tops, right? You would say that they would look or they would appear rectangular, right? And it looks like a tableland, but it's like it's surrounded by mountains. And it's normally called an intermontane. When it's surrounded by mountains, it's called an intermontane plateaus. Now I'll get to that later, right? So let me draw a simple plateau. Plateaus are normally those mountains with very steep sides. So you'd notice for most plateaus that the contour lines, right? Out you have the middle. Then you'll have the contour lines being close together because plateaus are normally very steep slopes, right? Now on the graph, it would be looking like this. And sometimes it may not look so perfectly. Yeah, it would look like that on the graph. Like this area flat. This island area so flat, right? Now, a long narrow strip of highlands, not mountains, no. The mountain, we have a long strip of mountains. We call that a range. But when you have a long narrow strip of highlands, you would call it a ridge. No. When you have long strips of highlands, let me write the word ridge right here. ridge. When you have a long strip of highlands, right? Now, this would have like the contours of ridges, they would be elongated and they would almost be parallel to one another, right? Now, the highest point of a ridge is called a crest. Now, let me draw a ridge, example of a ridge. Now, this is a representation of a ridge, right? Now, a ridge normally has a lot of river valleys because, as you see, river valleys and the watershed is like that long strip of water. This is called a watershed or a divide, right? So it's like what helps to, you know, right? So by the watershed, you'll then have what you would call the river valleys or the tributaries coming from them, right? Now, please remember, guys, that contour lines that go inwards are valleys, and when they go outwards, they are spurs. So these are valleys, and these are spurs, right? So please keep this in mind. As you can see, I mostly did it for, you know, rivers are located in the valleys because they're moving inward, right? Good. Now, the next feature that I'll be looking at is what we call a col or a saddle. Now, this is what we say it appears to be nulls on a map if you don't look closely, but they're actually not. They're totally different thing, right? Because sometimes even when I'm doing map reading, I often get confused because sometimes a null looks like a saddle. But the thing is, right, with the saddle, there's always two. So it's like you would have this almost, all right, let me draw it, right? So it's like you'd have two mountain peaks or two hills, right? On a land that is slightly lower than those peaks, right? Now the depression between those two hills or between those two slopes, a lot of people would call it a valley, but it's it's a col or a saddle. So the reason being, it shapes like a saddle on a horseback. Yeah. But in truth and in fact, how it would look on a graph, it would look like this. So this right here, it would be a col or a saddle. That right there, the depression, right? So normally how it would look on the map, like you would see this large area like of land that is slightly lower, right? It can be steep and it can be gentle, it doesn't really matter. But then you'd have these two. Oh, then you'd have these two areas. And these would be slightly higher. So say this is 8,500 meters, and this would be 1,500 meters. It happens, right? So these two areas of land would be higher than this region, right? So it's like some peaks, it's like two peaks in the middle of some contour lines. In truth and in fact, this is what that land actually looks like. Now this area right here where I'm putting the X, that would be the skull or the saddle. Now on to the last one, a cliff. Now a cliff is a very high or a very steep rock face. Now it's almost vertical and it's round, right? Now it is found either along the coast, a sea rift, or inland places. So normally you would see it going towards the sea. So you'd see it like this. Yeah, you see it going like this. And then the contour lines will become smaller and smaller, going from higher heights to lower heights. So this basically is what? So it's like you have this being 100, right? This right here being 100. And then this just dropped to 0. Right? It's just dropped to 0. Right? So let's say the distance between them is 15. So this is 115. Right? So it's like you have like this high, well, not really high, but it's like you have this contour line, let's say 100, and it just drops, right? There's no, it's just so steep. It's a steep rock face. This normally are found by the coast, right? These are normally These are normally found by coastal areas, right? So this is what it would look like. Or even steeper like this, right? That is what it would actually look like. On the exam, however, to indicate a cliff, you'd normally see some jagged edges. Like you see something like this by the edges of the map. Sometimes they would say that those are cliffs or rock faces, depending on what the key says. But for a majority of maps, this is what is shown. Right? So I hope you guys learned a lot from this video, and thank you for watching.